So let's talk about neural networks. What we really want to do today is we want to find an intuitive understanding about neural networks and what problem do they essentially solve for. So let's do this by taking an example. Let's say I have a certain number of scoops of ice cream. And given this scoop of ice cream, I have some internal logic by which I decide how many people I share this ice cream with. So if I have one scoop, I share it with one person, two. So this is the data that maps the logic I have. Now, given this data, if I were to ask you, how many people do you think I'd share this ice cream with if I had 7 scoops of ice cream? How would you decide? What would you do? Naturally, you'd look at the data given to you and you try to find some pattern. And looking at this data, the pattern seems almost straightforward. You'd say, hey, you'd probably share it with 7 people because there's a direct correlation between the number of scoops of ice cream and the number of people I shared with. So now let's further take some time and draw this data out on a Cartesian plane. Let's graphically represent our problem. So say the y-axis has the people I share with. So I'm just going to write share, the number of people I share with. And on the x, I have my scoops of ice cream. So I'm just going to write scoops. And let me just take a moment to plot the data that was given to us. So we have this right here. So 1, 1 is our first row of data, 2, 2, 3, 3, and 4, 4, so on. Just looking at this data, you can see that if I were to fix a line through these points, they'll just simply pass through all of them. Furthermore, I can expand this line backwards. How does that help? Well, now if I were to ask you again, how many people I'd share my ice cream with if I had 7 scoops of ice cream, all you have to do is look at the corresponding y-coordinate for this certain 7x coordinate on this line. And certainly, that would correspond to 7. Graphically representing this problem really helps us because now we can clearly understand the steps to solve such a prediction problem, right? One, we can just plot our data. So we have some given data. Let's just plot our data. That's step 1. Step 2 is find a line. And we'll see later that it's not always going to be a line, and this line is not always going to fit the data accurately, but in this case it does. And when I say find a line, I essentially mean find an equation of a line, right? So the equation over here is pretty simple. It's y is equal to x. We know that for any point on this line, y and x have the same value. And once we have step 2, which is perhaps the most essential step, the third step is pretty easy. Now it's just predict. Let me just write that clearly. We just predict for some value of x, the output y. So even if I were to ask you what would you think the number of people I share the ice cream with would be if the number of scoops was 17, we would do essentially the same number of steps. Now, this data was fairly straightforward, and we could do all of this merely by observing a few rows of the data. But let's reimagine this problem, and let's see what happens if the same problem, the same y-axis and same x-axis, but the data would look something like this, scattered across the Cartesian plane. Now, how do you know which line passes this data? It could be this one, but it could also just be this one. Which one is more accurate? And how do we know a line is the best fit for this data? Could it be a curve? Furthermore, let's think about this problem in higher dimensions. What if we take 3 dimensions into account? What if my output, that is to predict the number of people I share this ice cream with, didn't just depend on the scoops of ice cream, but also perhaps the flavor of ice cream? What if I don't like sharing chocolate as much as I do with mango? Right? So the data would be plotted across 3 dimensions now. How do you know what equation fits this data? And here comes neural networks. This is essentially how neural networks help. So say this is a neural network. What they tell us is we have a bunch of data which has some input, which is, say, scoops of ice cream in our case, and some output, what we want to predict, which is number of people we share with, right? So this is the output. Neural networks tell us that give me this data, and I will do some computation inside this box. I will do some computation, and essentially I will come out trained with that equation of line, curve, plane, whatever it may be, depending on the dimensions, depending on the number of input features. I'll come up with that equation that fits the data well. And once I have that equation, I essentially have covered the step 2 mentioned over here. You can use me to predict for any x unknown. So x unknown goes inside a trained neural net, and we'll look at how we train a neural net later, and we get some prediction of y output. And if we have trained our neural networks well, the output would actually look accurate. So think of neural networks as function approximators that try to find the best fit of a curve line equation for a given set of data, such that we can make predictions. Now, that is a very intuitive understanding of neural networks. There are obviously a lot more terminologies, there are implementation, there's math. If you like this video, you can perhaps check out the rest of my videos on this topic to get some more understanding on neural networks.